All right, here's some problems on wavelength, frequency, and energy of a photon. Photon has a frequency of this many hertz. Remember, that's the number of waves per second. That's a gigantic number. Number of waves coming past per second, which means there's probably a really small wavelength if it's that high of a frequency. Figure out its energy in joules per photon. Sometimes they call that joules per electron, and kilojoules per mole of photons, or kilojoules per mole of electrons. So we know the frequency and we want to get energy, so we can go the energy equation here. Energy equals that. So energy equals 6.626 times 10 to the negative 34th. That is called Planck's constant. So that's just a constant. Notice that is in joule seconds. And we're going to multiply by waves per second, which will just give us an answer in joules. Okay, so know when you're using this, your answer is going to be in joules. So that times 2.68 times 10 to the 15th waves per second. Energy is 1.78 times 10 to the 18th, I believe. Sorry, negative 18th. Joules. That's a really small number. 0.0000178, a bunch of zeros, 178 joules. That is the number of joules per photon or per electron. Okay, however you want to say that. Joules per photon. If we want to get that into kilojoules per mole of photons, we're going to go 1,000 joules is a kilojoule, so that and that can cancel. We'll be left with kilojoules per mole. So it's per photon right now. We can say that there are 6.02 times 10 to the 23rd photons or electrons per mole of photons. You end up with 1069 kilojoules per mole. So first answer, really, really small in joules per individual electron. Kilojoules per mole of electrons is going to be a much bigger number. Number two here, figure out the energy in joules and wavelength of radiation with the frequency of this. So we have frequency, we need to get energy, need to get wavelength. And it's 92.5 megahertz. Now, first thing, 92.5 megahertz, I would give you this conversion. 1 megahertz is 1 million hertz. So 9.25 times 10 to the 7th hertz. Remember, that is waves per second. Waves per second. We need energy and we need wavelength. Energy and wavelength. So we got it. Energy, just like we did above, and here to get wavelength. So for energy, we would take Planck's constant, 6.626 times 10 to the negative 34th. Remember, that is in joules, times 9.25 times 10 to the 7th hertz. You get an energy of 6.13 times 10 to the negative 26 joules. I'm going to say joules per photon. Does not want it in kilojoules per mole. If we want to get the wavelength, c is the speed of light. Does not change. So wavelength times frequency. So we're going to go 2.998 times 10 to the 8th equals, trying to solve for wavelength, frequency is 9.25 times 10 to the 7th. Hopefully you guys can still see that. Divide over to this side, so take this divided by this, and you get a wavelength of 3.24. Label. Speed of light is in meters per second, so your label is going to be in meters. I'll do that problems in other videos.